Exercise 1b. So the topic for exercise 1b is highest common factor, or which is known as HCF. So what is the highest common factor? We will get this topic with the help of an example. Suppose we have to find the highest common factors of 18 and 30. So first of all, we need to understand what is factor. So 18 can be divided by 1, can be divided by 2, can be divided by 3, can be divided by 6, and can be divided by 9, and can be divided by itself, which is 18. So these are all factors of 18 because they all simply can divide 18. So they are known as factors of 18. And in the same way, we have the factors of 30, which are 1, because 1 can divide 30, and then there is 2, there is 3, there is 6, and there is also 5, and then there is 15 and 10 as well, and 30 itself. So these are all factors of 30 because they all can divide 30 totally. So between the factors of these two values, we see that 1 is a common factor, 2 is also a common factor, 3 is also a common factor, and then 6 as well, and then there is no other common factor between these two. So the term HCF, or highest common factor, suggests that we choose the highest common factor between these two. So the highest common factor between 18 and 30 is 6. So we can say that highest common factor of 18 and 30 is 6. So 6 is the HCF of 18 and 30. We can also find the HCF, or highest common factor, of 18 and 30 with another method. The other method is that we write the value 18 and 30 like this, and we have to divide these two with the same prime factor. So as we can see that 18 and 30 can be divided on 2, so 2 9s are 18 and 2 15s are 30. And then we have to divide 9 and 15 with the same common factor. As we can see that 9 and 15 can be divided by 3, so 3 3s are 9 and 3 5s are 15. And then 3 and 5 cannot be divided on the same common factor, so we will stop right here and we will be left with these two. So we can write that HCF, or highest common factor, of 18 and 30 equals to 2 times 3, which is 6. So we can find the highest common factor of 2 values or 3 values with these two methods. Most of the time we are going to use this method because it is easy for greater values, and this method is not easy for the greater values. And another method of finding HCF is as follows, that first of all we have to factorize these both. So 18 can be factorized as 2 9s are 18 and 3 3s are 9 and 3 1s are 3. So 18 can be written as 2 times 3 times 3 times 1, and then 30 can be written as 2 times 5 times 3 times 1. So 30 can be written as like this in its factorized form. And now we have to see that these 2 and these 3 are common in them. So the HCF will be the product of these two common factors, which are 2 times 3, which is equal to 6. It is also another method of finding the common factor of any two values or more than two values. And the next topic is the lowest common multiple, or which is known as LCM. So first of all, we need to understand the term multiple. By multiple we mean that if you want to find the LCM of, let's suppose, 6 and 10. So the multiples of 6 are, first of all, 6 itself, because 6 times 1 is 6, and then 6 times 2 is 12, and then 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, and 6 times 6 is 36, 6 times 7 is 42, and so on. And in the same way, the multiples of 10 are 10 itself, because 10 times 1 is 10, and then 10 times 2 is 20, and 10 times 3 is 30, 10 times 4 is 40, 10 times 5 is 50, and 10 times 6 is 60, and 10 times 7 is 70, and so on. So these are all the multiples of 6 and 10. So then we have to just find out the lowest common multiple. So between these two values we have to find the common multiple first of all. As we can see that 30 here and 30 here are the same, so this is a common multiple. And if we extend the multiple of 6, it will also reach at the 60, because 6 10 times is 60, and then so on. And then there is another common multiple between 6 and 10, which is 60. So out of these two common multiple, the lowest common multiple is 30, because 30 is less than 60, so the LCM of 6 and 10 is 30. So by lowest common multiple, we mean that we have to find a number which is a multiple of both of these, and it is the lowest common multiple between these two. And another method of finding the LCM of 6 and 10 is that we factorize 6 and 10. So 6 can be factorized as 2 times 3 times 1, and 10 can be factorized as 2 times 5 times 1. And then we have to find LCM. Then LCM equals to, since there is a common factor 2 which will be written one time, and in LCM we write the common multiple times the non-common multiple. As we can see that this 5, 3 and these 2, 1 are common multiple, so 2 times 1, these both are common multiple, and these 2 are non-common multiple, so we have to write the non-common multiple as well in LCM. 2 times 1 is 2, 2 times 3 is 6, 6 times 5 is 30, so LCM of 6 and 10 is 30. And there is another method for finding the LCM of 6 and 10, which is that we have 6 and 10, and we have to divide these two on a common factor, which is 2. So 2 3 is 6 and 2 5 is 10. And then as we can see that there is no more common factor of 3 and 5, so we have to proceed with 3 times 1 is 3, and 5 cannot be divided by 3, so 5 will remain as it is. And then 5 times 1 is 5, and 5 cannot divide 1, so 1 will remain the same. And then LCM will be the product of these values, so 2 times 3 times 5, which equals to 30. So we can find the LCM of 6 and 10 like this as well. The difference between this method of LCM and this method of HCF is that in HCF, when we can't divide these two values with the same common factor, we stop, and the common factors which divided these two values is the answer for the HCF. Then we multiply these two, which will be 6, which is the HCF of 18 and 30. But in LCM, when we can't divide two values with the same common factor, we just proceed with the factor of one of the values. So 3 times 1 is 3, and 5 will remain the same. And in the next step, we are going to divide 5 with 5. So 5 1s are 5, and we will be left with 1 and 1. And then we have to multiply these three values to get the LCM of 6 and 10. Now we are going to solve the exercise 1b with these methods. Exercise 1b, question number 1. Find the highest common factor of each of the following sets of number. So we have to find the highest common factor of these values, or highest common factor can also be termed as HCF. So first of all, we are going to factorize these two values. So 12 and 30 should be factorized. First of all, we are going to prime factorize 12. So 2 6 are 12, and 2 3 are 6, and 3 times 1 is 3. So 12 can be written as 2 times 2 times 3 times 1. And so we are going to factorize 30. So 2 15s are 30, and 3 5s are 15, and 5 1s are 5. So 30 can be written as 2 times 3 times 5 times 1. and then we have to find HCF common. So these are the factors of 12 and 30. Now we are going to find the common factors. So the common factor here is 2, and another common factor is 3, and another common factor is 1. So we just have to multiply these common factors. So we have 2 times 3 times 1, which equals to 6, which is the HCF of 12 and 30. And as we can see, 6 is the highest factor of both of these, because 6 can divide 12 as well and 30 as well. And in part B we have 84 and 156. Now we will find the HCF of these two values with another method. We have to divide both of these values at a time. So 84 comma 156. So as we can see, both of the numbers are even, so they can be divided with the common factor of 2. So 2 and 2 4s 8 and 2 2s 4, and then we have 2 7s 14. So 15 minus 14 will be 1. 1 will be given to the 6, which will become 16. So 2 8s 16. And then again 78 and 42 can be divided with the same common factor, which is 2. So 2 2s 4 and 2 1s 2, and then 2 3s 6. So 7 minus 6 will be 1. So 18 3 2 9s 18. And then we can inspect that 21 and 39 can further be divided with a common factor, which is 3, because 3 times 7 is 21, and 3 1s 3 and 3 3s 9. And further we cannot divide 7 and 13 with the same common factor. So we are going to stop here, and we can say that HCF of 84 and 156 equals to 2 times 2 times 3, which equals to 2 times 2 is equal to 4, 4 times 3 is equal to 12, which is the highest common factor of these two values. And then in part C we have three numbers which are 15, 60 and 75. We are going to solve these with this method, with the method of factorization. So first we have to factorize these three values. So factorization of 15 is simple, because 3 5s are 15 and 5 times 1 is 5. And then we have 60. So 2 30s are 60 and 2 15s are 30. And 3 5s are 15 and 5 1s are 5. And then we have to factorize 75. So 75 can be divided with the table of 3. 3 2 times are 6. So 7 minus 6 will be 1. So 3 5s are 15, and then 5 5s are 25, and 5 1s are 5. So 15 can be written as 3 times 5 times 1, and 60 can be written as 2 times 2 times 3 times 5 times 1. And then we have 75. 75 can be written as 3 times 5 times 5 times 1. And then we have to find out the common factor. The common factor of these three is 3, because 3 is common in all of them, and another common factor is 5 between all these three. So the HCF is given by the product of the common factors. So the common factor were 3 and 5. So 3 times 5 is 15, which is the highest common factor of these three values, because 15 can divide all of these three values. So it is the highest common factor of 15, 60 and 75. And then in part D we have 77, 91 and 143. So first we have to factorize all three of these. 77, so 7 11s and 11 times 1 is 11. And then we have 91. 91 can be divided with the table of 7. 7 1s are 7, so 9 minus 7 is 2, 21. So 7 3s are 21, and then 13 times 1 is 13. And then we have 143. 143 can be divided on the table of 11. 11 ones are 11, so 14 minus 11 will be 3. 3 will be given to 3, so it will become 33. 11 3s are 33, and then 13 ones are 13. So 77 can be written as 7 times 11 times 1, and then 91 can be written as 7 times 13 times 1, and then 143 can be written as 11 times 13 times 1. So in all the factor of these three values, the common factor we can get in all three of them is 1. So we can say that HCF of all these values is 1, because there is no other factor. We can see that 7 is common between these two, but 7 is not present in the factors of 143, so it is not a common factor between all three of them. So the HCF of these values is 1, because 1 is the highest number which can divide all three of them. There is no other value other than 1 which can divide all three of them. That's why HCF of these three values is 1.